Hi guys, we'll be solving Leetcode 518 coin change 2. I hope you have seen the coin change 1 problem that I've solved before. If you don't find it, I'll try to link it in the video down below in the description. Or else you can go to my YouTube and check my video on coin change 1. Before solving coin change 2, I suggest you guys to see that video once to brush up all the basics and then come back and see this video. Okay. With coin change 2, let's study the problem statement first. Okay, so you are given 3 coins, 1, 2 and 5, and you have to make 6 as an amount, as an denomination, right? So in coin change 1, they gave us find the minimum number of coins with which you could have made this amount, right? So earlier it was 5 comma 1, that gives you 6, just 2 coins, right? In coin change 2, they are asking us to get all possible combination of coins that will form this amount. Okay, so it can be 6 times 1. Can you guys see? Yeah, it can be 6 times 1. Then we have 2 as well, so it can be 2 times 3 times 2, or it can be 2 times 1 plus 4 times 2 times 2 plus 2 times 1, or 2 times 1 plus, that is 2 times 2, that is the same. But if you guys think, we want all possible combinations, right? Not the minimum combination, now all possible combinations. They are expecting us to give them a number, not all the combinations, right? But if you had to do all the combinations as well, you could have done it in the recursive way, right? So in coin change 1, we have solved the recursive approach of this, but we will not be going into that depth in coin change 2. If you want to go brute force, you can still think to see coin change 1 and come back see coin change 2, right? We'll still be coding it out, the brute force approach, the recursive approach, but we will not be explaining it here in the board, right? So yeah, I've taken a matrix again. I'm trying to do the optimized approach here, the DP approach. I've taken a matrix. We have coin 0, coin with denomination 0 as the value 0, coin with value 1, coin with value 2, and coin with value 5, right? And we have all of these amounts, amount 0, amount 1, 2, 3, 4, 5, 6, right? Starting with basics, I'll keep 1 here. Let's figure out why I have 1 there later. Okay, with 0, can you make 1? No, so 0 possibilities. With 0, can you make 2? No, 0 possibilities. With 3, no, 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 right? Why 1? With 0, can you make 0? With 0 as a coin, can you make 0 amount? Yeah, you can make it, hypothetically, yes, right? So I have 1 there. Let's try to go ahead. Earlier, when you initialize a matrix, it will all be 0, right? We'll think about this part of the matrix now, right? So with 1, can you make 1? Yes, 1 cross 1. So yes, you can make it, you can make 1. Okay, what's the 0 case? So with 0, can you make 1? It's 0, right? So it's 1 plus 0 here. Why plus? Because now I want all possible combinations, not just minimum number of coins, but all coins that can make up to an amount, right? So we are done with 1 and 1. Now we have to check 1 and 2. Can you make 1 and 2? So with 1 and 2, 1 cross 2, that is just one possibility, right? That's 1. Will with 0, can you make? So no, plus 0. So same, when you see with 1, it's all 1, right? Things change with 2 now, right? So with 2, can you make 0? No. Can you make 1? If you try to make 1 as an amount with 2, right, you will not be able to make. So even if you take 2 cross 1, it will be 2, so your amount will be, right, you will go minus. In the recursive approach, we were not allowed to go minus, right? So whenever we are the amount is below the coin's value, we'll just take the amount above, because 1 comma 0 can make 1, and 2 we'll see it later, right? 1 comma 0 can make 1, that will be 1. Now let's go ahead. With 2, can you make 2? Yeah, you can make it in one possible way, right? So it's 2 cross 1 is 2, right? So that's 1 here. With 1 comma 0, rest of the coins that we have already computed for, can we make 2, right? With 1 comma 0, can we make 2? We have solved this problem, just the case above. Yes, you can make 2 in one option, that is 1 cross 2. Taking 1 as a coin 2 times gives you 2, right? So 1 plus 1, that is, sorry, 1 plus 1, that is nothing but 2. Right? Try to erase this. Okay, so with 2, can you make 3? You can make 3, yes. 2 cross 1 plus 1 cross 1, right? So 2 cross 1, have we did this? Yeah, you take this coin once. And 1 cross 1, have we done this? Yes. So that's here you can make 3 in 2 possible ways, right? So 2, and the remaining set of coins, if you don't choose 2, you have to choose these coins, remaining set of coins, right? So there you can just see the case above, that is 2 plus 1. So this turns out to be 3. So there are 3 ways in which you can make the amount 3 with coins 1 comma 2. Does that make sense? Yeah. So this is 3. For 4 also it will be 3. So this is 4 and then this is 4. Okay. With 5 again everything changes. With 5, if you try to make amount 1, we'll go negative. So we don't want that. Just take the value above. So that is 1. With 5, if you make 2 negative, just take the value above. Same 3, 3. With 5, can you make 5? Yes, you can make 5, right? You can make 5. So that is one possible case. That is 5 cross 1 is equal to 5. If you don't choose 5 to make the amount 5, you gotta choose the remaining set of coins, right? These coins. So where do you get those values? Just the case above, that is 4. So with coins 1 comma 2, there are 4 ways that you can make the value 5, right? So we want the sum of all the possible combinations. So 1 plus 4, that is 5. That's 5. Right? Now with 6, you gotta check. What were we doing in coin change 1? We were coming back the number of steps of the coin, right? Here as well, we'll see with 6, can you make 5? With 5 as a coin, can you make 6 an amount? So we have the amount as 6. 5 cross 1 is equal to 5. We are remaining with what? 1, right? 5 negative, right? So with 5, can you make 1? So 5 remaining amount 1, we have it already here, right? So just take it from here. There is one possible way, plus 1, and then as you see, if we don't choose 5, you will have an explanation above. So yeah, that is how. So we'll try to code this problem out. Okay, so we'll try to do the recursive approach here. We'll try to do a int-based recursion. Helper will have the index as 0 starting, then amount and coins, right? Public int helper int idx int amount int array coins. We'll write the base cases later. Int case 1 is equal to helper. So let's do not choose, or let's do choose first. Choose, right? If you choose, you have an infinite supply of the coins. So we'll do idx. Amount will be amount minus coins of idx, and coins remains the same, right? Not choose. In case 2, helper idx plus 1. Now we are not choosing it, so we are skipping that coin, and not choosing, so it's not contributing into our amount. And coins, what were we doing in the coin change 1? We are trying to do mat.min, right? You're trying to get the minimum number of coins through which you can form the given amount. But here we want all possible combinations, so return case 1 plus case 2. Base case, if we run out of indexes, index equal to coins dot length or amount is less than 0, right? So we don't want our amount to be negative, so in that case there is no possible combination, so return 0, right? Now if amount equal to 0, that means we have found a combination, return 1, right? This is our base case. I'm sorry guys. Yeah, so yeah, this is our base case. So it passes. Yeah, time limit exceeded, right? Let's try to optimize this. Let's do a dp int array. Let's int m is equal to row should be at coins dot length, right? And int n is equal to amount, right? Array dp new int should be m plus 1, because we are taking 0 as well, right? In coins we had a 0 row and 0 as a column as well, so we are taking n plus 1 and n plus 1, right? Our dp of 0 and 0, by default when it's being initialized, it's initialized with 0, that's fine, but our 0 comma 0 should have been 1, right? We did 1 there, so you can make 0 as an amount with 0 as a coin, right? So that's there. Let's start our loops for int I is equal to 1, I is less than equal to m I plus plus, right? For int j is equal to 0, j is less than equal to n, j plus plus. Okay, if j is less than the denomination of coin, that is I minus 1. Why I minus 1? Because our I is starting with 1, just because we have a 0 as well in the row, but in our actual coins array we don't have a 0, so we are gonna do I minus 1, right? So if you don't have the denomination of the coin, else it's a different case, right? If you don't have it, that means dp of I and j is just the value above I minus 1 and j, right? But if you have it, then dp of I and j is dp of this thing plus we were doing the other thing, right? So plus dp of I, the same row, and those many columns back, those many columns. What is those many? Those many is the denomination of the coin, the value of the coin, right? So j minus coins of I minus 1. Okay, what are we returning at the end? We are return the last index, dp of m and dp of n. It says dp of I minus 1. Okay, it runs just fine. Okay, but at any given condition, as we checked in the matrix, we were using just the row above, right? And we are also not changing the values and then still using the older values as the row above, right? So then we don't need a matrix, but one single array should do this. If you see, we'll just go all the number of amount plus 1 because we have 0, and we would take off all the first values. j minus, and then remove this as well. Let's see if this runs. But yeah, this runs. But as you see, I'm not changing this value here. Instead, we can do greater than equal to and only change these values, right? If you see, I have removed this. I have done plus equals to. I have removed the else condition as well. Now this should run fine. So yeah, that's your optimized approach. M cross n in this case, and space of n being amount plus 1, right? If it was recursive function, we are having two branches running out through one node, so 2 raised to mn, right? Yep, m plus n, 2 raised to m plus n. Okay, thanks guys.